2. So, quick introduction if we haven't met yet. Hi, my name is Anoja. I'm a product education specialist here at MaintainX. Essentially, that means I'm responsible for creating educational content and learning experiences, sort of like the one that you're in right now. And today I'm being joined by Colin. Colin, do you want to give an introduction?
Yeah, thanks, Anoja. Really good to be back here. My name's Colin. I work in product marketing here at MaintainX. I specialize in our asset intelligence solutions. So really any tools or integrations that support condition-based and predictive maintenance. So really excited to help out here today.
Thanks for being here, Colin. Very special guest today. Now, today on the agenda, there is a ton, as you can see. We're going to go through an introduction to condition-based maintenance, and then we'll talk about meters, then automation, then reporting and insights. We'll leave room for a frequently asked questions section, and then we'll also share some resources. And we have a special announcement, so please do stay until the end to hear what that's all about. Some housekeeping items. Is this webinar being recorded and will I get a copy? Yes, of course. We always send a copy of the webinar and you should receive it by email by September 25th. And then how can I ask questions throughout the webinar? So we do ask that if you have a question, you submit it through the Q&A tab that you'll see on your screen. So similar how there's a chat tab, we ask you to go to Q&A and submit your questions there. We've got a couple of reps from the support team, Louise and Tan, who will be answering your questions live. So please do submit them in the Q&A section if you can versus the chat. Now, a little bit about MaintainX for those of you who don't know about us. Our mission here is to transform the way that frontline professionals manage the equipment and the facilities that power our world. So we're pushing innovation in mobile workflows and real-time analytics and open APIs. And we are a world-class team here that develops and supports our product with industry expertise in manufacturing, facilities, and more. And then we've got some awards here on the right side. I will admit I forgot to update these. These are our summer awards, and we actually have a bunch of new fall awards. But as you can see, we're not just seasonal, right? All throughout the year, we've got summer awards, fall, winter. There's a whole bunch. So just if you needed some more proof of the work that we're doing here at MaintainX. All right, now condition-based maintenance. So I'm going to turn this back over to you, Colin, but a couple of questions to get us started. Now, what do we mean when we say condition-based maintenance? And how is condition-based maintenance different from more traditional approaches like preventive or reactive maintenance? And then why should organizations consider shifting towards CBM?
Yeah, so I'll start with the why. So it can be really tough to keep equipment running, right? If you're not monitoring how it's doing. Even if you do a great job of staying on top of your PMs and your inspections, you're still going to be caught off guard sometimes. So that's why condition-based maintenance is important. That's why we're talking about it today. It's basically a smarter way to use your data to catch issues and address them before your equipment goes down. And then the main difference here, I would say, instead of relying on calendar-based schedules for PMs, what you're doing is you're using meter readings or sensor data to trigger the maintenance. So it might be that a machine is running at a higher temperature or pressure than it should be, or there's an excess vibration, but there's some sort of condition-based signal that's usually coming from a meter or a sensor that reveals an issue that needs to be addressed. So just by paying attention to the signals you're getting from the equipment, you're going to be more likely to prevent failures. And then over a long period of time, that can help you to keep the machine running and extend its life as well. And also, I think by being more precise about when to do the work, it's usually more cost effective as well. Because not only is it helping you to reduce some of that reactive work that usually carries a higher cost, but also if you think about running a standard PM strategy on a calendar, there's going to be times where the equipment might not necessarily need servicing, right? So this is helping you to optimize that and avoid some of that premature or unnecessary work. And you can see here in the top right, more than 30 hours a week are spent on scheduled maintenance in nearly a third of plants. So that's a huge amount of time that's tied up, in routines that might not even be necessary. So another benefit to condition-based maintenance, or CBM, as we're going to refer to it a bit throughout this webinar, you'll be able to free up those resources to devote to more urgent or more important things. And so if we look at this in comparison to other maintenance strategies, there's a long-standing framework here of maintenance maturity that we can use for context. You can see condition-based maintenance kind of sits in the middle here. So Just to kind of walk through these quickly, reactive, this is the least developed strategy. Um, wait for the machine to fail and then fix it. This is the most costly, the most stressful strategy, particularly in industries like manufacturing, where your production often depends on certain machinery being available. But nobody wants to be firefighting like this, right? It's usually the result of not having the data or the tools to be more proactive. And this is exactly what brings a lot of folks to MaintainX. So if you're still at this point today, or predominantly at this point, at least you're taking the right steps to evolve, and we're obviously here to help you with that. Next up, preventive maintenance. So I imagine most of you are doing at least some of this today. So that means maintaining your assets on a schedule, whether that be calendar-based or usage-based. So here you're trying to catch things early, and this is obviously much more proactive and cost-effective than running machines to failure. Usage-based preventive is a bit more advanced, right? Because there's a dynamic element to it. This means you're doing your PMs based on run hours or cycles instead of time. And the idea there is that, let's say the equipment hasn't been operational for whatever reason for a period of time. You're only going to service it when it's likely to need that work the next time. So then we have condition-based. That's what we're really here to discuss today. Similar to usage-based, you're using some real-time data here to trigger your maintenance, but it's a little bit more complex than the usage-based PM, because now you're talking about things like temperature, pressure, vibration, things that are more to do with the health and condition of the machine and may have quite frequent readings being taken. So we're going to spend a bit of time today talking about how you can get here. Obviously, you need the tools to monitor your equipment. We're going to show you how to do that in MaintainX today. You'll also need to be able to define what an abnormal condition looks like, so that you can take action on it, right? So I would say your OEM manuals will be a good starting point there, but you can also use some of that inspection and failure data that you have in MaintainX to get smarter about what those trigger points should be. And again, we'll cover more of this in a moment, but essentially what makes condition-based maintenance a more mature strategy is that you're using real condition signals from the equipment to trigger the maintenance. And that's going to make it typically more effective than using a time-based schedule. I'm not going to spend too much time on these more advanced strategies today, but this is what you're laying the foundation for, basically, by deploying a condition-based maintenance program on your more critical machines. Because once you have enough historical data on the asset, you can then start doing predictive maintenance. And this means using trend analysis to predict when the machine is likely to fail next, so that you can, of course, intervene to prevent that from happening. And now, of course, there's a lot of AI technology that can process all this information way faster than a person can. But you can also use the trends in MaintainX to spot some of these things yourself. And then finally, predictive. So here the system is not just prescriptive. Here the system is not just predicting a failure, but it's telling you what you should do about it as well. This is going to be an aspirational state for most of us here today. But I think what really matters for our discussion today is really just this idea that each of these stages kind of enables the next, right? So just shifting some of your PM to condition-based maintenance is going to be a really important milestone for a lot of folks here, because it's really the first step towards those more advanced maintenance strategies. And I will say as well that all of these strategies have their place. So even the most mature companies out there are still doing some reactive work. The strategies that you use will really depend on the asset, and generally speaking, the more critical it is to the operation, the more worthwhile it's going to be to take a more advanced approach to maintaining it. So with that, let me know what you guys are doing predominantly today. I've gone through there some different maintenance strategies. Like I said, you might be doing a mix of two or even more of these strategies, but let us know where on that model you guys see yourselves predominantly today. And just remember to use that poll tab on the right side of the screen. All right, so we're seeing as expected, we're seeing a mix of reactive and preventive. There's a little bit more preventive there, which is great to see. Um, just starting to see predictive coming in. Nothing for condition based yet, but at the end of the day, that's why you guys are here. All right, so let's continue. So we got a good basis to move from here.
I think so. Yeah. I was wondering, would there be people that are already working on condition-based maintenance? I thought it would be low, so I'm glad to see that it's what we expect. Just that way we can teach you folks what we know. All right, now let's get into specifically the features within MaintainX. So meters. Now, Colin, what is a meter in MaintainX, and how do meters help organizations track equipment conditions? And then what's the difference between manual meters and automated meters?
Yeah, so great question. This is going to be a really important starting point. Meters are the backbone of your condition-based maintenance program, essentially. So these are the things that measure and record how your equipment is running and performing. This is where the data for your condition-based maintenance program is going to live in MaintainX, and it's really going to power a lot of the things that a Noder actually is going to cover after my piece here. So the benefits of using meters in MaintainX, you're going to get real-time visibility into equipment condition, plus historical data that gives valuable context on how your assets are performing over time. And we're going to show you today how you can turn that information into an effective preventive strategy that's going to help you to reduce your downtime. And you can see a quick example in the top right corner here. Again, I remember chatting with these guys at Coltrack. They were running at 5% unplanned downtime. They managed to get that down to 1.5%, using the meter data in MaintainX to trigger the work, which is a really incredible 70% reduction. And last thing before we jump into the demo, you did ask me as well about the difference between manual and automated. So the difference is really how is in how the information is populated into the meter. So a manual meter requires your technician or somebody to take a reading themselves. That could be keying in the mileage on a forklift, or it could be taking a temperature reading from an HMI. The automated meter, on the other hand, is connected to an external system like a SCADA or an IoT device. And the data there is going to come in automatically from that other system. So you don't need to take the readings manually. I'm going to show you a few examples of that in a moment. But if you're using Ignition, for example, a lot of our customers are using Ignition. We have a very streamlined connector that's going to help you there. This is going to be really beneficial in terms of the accuracy and frequency of the data collection. But it's also going to save your team time from having to take those manual readings. Of course, you do need some additional tech for this to work. You're going to need a system or some sensors in order to make that work. But I'll show you how it's done in the system today, and I'll also share some best practices later for the types of equipment or the types of scenarios where you might want to start looking into how to bring in more OT, IoT technology. All right, so just before we jump in, curious here, are any of you using meters already today? And if so, have you connected any automated meters yet, or are you just using the manual meters? So let us know in that poll again, you can find on the right, just before we jump into the demo here. Okay. So we got a few, great, a few using both, but mostly manual. Again, pretty much what I expected there. So it's going to be really cool to jump in here and show you the different ways we can use meters. All right, so I'm just going to give you a quick tour here of the meters module. So what you're seeing here is our typical MaintainX organization. If I jump down to meters here, I can see this is where my meters live, and I currently have 5 here. I'm looking right now at this top one, which is the runtime hours for this Dur paint robot. And you can see right away on the right that I'm seeing some kind of light analytics here. So I'm seeing the latest readings that have been taken on this meter, and this is of course an hour operating hours. I can also change the time frame here, so I want to look over a longer period of time. You can see over a month the previous readings that have been taken. So this gives me like a very quick snapshot of how this machine is running. You could imagine here all this being temperature or pressure or various different condition signals. And then as I scroll down, I'm able to see as well when the last reading was taken. If there's a reading frequency specified for the meter, I can see when the next one is going to be taken. And Anoja is going to talk a little bit about this later, but you can also see any automations that have been attached to this meter. So we come to showing you how you can actually turn this data into action. This is a really easy way for you to see automations that have been set up using this particular metadata, and you can kind of browse them and manage them from this part as well. So what I'm going to do is I'm just going to create a new meter. Here, let's say I'm going to call it a wrapper hour meter. And if I just start by looking at the manual meter first, because I know a few of you said there in the poll that you weren't using meters at all. So what you can do here is you can give it a description, your measurement type here. So we have a range of different measurement types, right? And this depends completely on the type of value that you want to capture in the meter. So you can see we've got some some that are specialized to temperature. We've got Celsius, Fahrenheit, Kelvin there. And then down here, we've also got, so these are runtime related meters. You've got hours and cycles, but then you can also capture weights, levels, and things like that are going to help to cater to various different types of equipment. So here we're going to go with hours. I can now attach the meter to the asset. That's really important because what that's going to do is make sure that all the information that is captured by the meter is kind of centralized into that specific asset. And what you can also do with that is, when you're looking at this asset from its specific asset page, you're also going to be able to see your attached meters there and monitor some of your condition and usage data directly from there. You can also add a picture. So let's say I add this here, and I've added a picture of the machine here, and it just means that as I'm kind of scanning this meter list, I'm going to be able to make sure that I see it, create that. Now, what you can do here is you remember to use this filter at the top as well. If you want to see all your meters related to a specific asset, I can filter there. And so obviously, if you have a lot of meters in here, it can get a bit cluttered. So that's a way to kind of make sure that you're only seeing the meters for a specific asset. Now, when it comes to actually capturing readings on a meter, there are various ways that you can do it. You can see right away, I can record a reading here immediately through the meters module. What's going to be probably more useful for you guys, though, is to actually create work orders that will require a meter reading to be taken. So this is how you can actually make sure that the readings are being taken with the frequency that you want. It's actually assigned to somebody to go and take the meter reading. And so there are a couple of ways we can do that. And we're actually going to come back to work orders now to see this because, well, actually, sorry, I will show you one thing here. So one of the ways that you can do it is if you click on these three dots in the top right of the meter, you can see here, use a new work order. So if I want to ensure that somebody is going to take this runtime hour reading, I can click that button and it's going to create a work order. And if I scroll down here, you can see that the meter reading is embedded into the work order as a procedure. So what I can do is I can now set a due date on this. I can set a recurrence. I can set a priority. I can make sure that it's assigned to somebody so that somebody is actually going to go out and take that manual reading. So another way you can do it is this is an existing work order here. This is an existing inspection for our paint robot. And if I scroll down here, you're going to see that there's already a procedure in here with this meter reading embedded. So this is really the most effective way to get those meter readings taken. If somebody is going out to do an inspection or PM on a machine, you can include a meter reading field in the procedure to make sure that this reading is being taken each time. Now, something also cool that I want to show you here is a feature on our enterprise plan called anomaly detection. So as meter readings are being taken, there may be certain types of action that you want to take immediately after that reading has been taken. Now, one very, very basic example is that somebody might type in the wrong amount, right? When you are dealing with manual meters, somebody is having to take that meter reading manually. So if I was to put in, for example, here an extra 0, what's going to happen is our anomaly detection has flagged this, right? And what it's saying is that this value looks out of place from what we would expect, given the recent range of this meter and how it's been progressing over time. And clearly, if this was to be put in as an hour count, this could be consequential because if you do actually have hour-based maintenance activities that are being triggered by these runtime hours, and somebody puts in a value that's a lot higher, now you're going to start getting, potentially work orders, PMs being triggered based on this higher value that you don't actually want. It's a mistake, right? So this feature allows us to do a couple of things. First of all, if this is an error that somebody has just typed in the wrong number, they will see this and they can simply correct it. But this anomaly detection feature also is really helpful for condition-based maintenance programs because if you are running, let's say, a temperature meter or pressure meter in here, and this reading has flagged something that's anomalous, it might not be a mistake by the technician. It might actually be that there is something unusual about this condition or pressure data that's coming through. And now, if this is marked as an anomaly here, they can take a picture of the meter um, as well, additionally. And now, when they mark this work order as done, it's going to prompt them to create a corrective action. So basically what you've done is you've captured the moment where something unusual or abnormal has been detected on the asset via the meter. And now what it's doing is it's asking you if you want to create a corrective action on that machine to make sure that that issue is addressed. And there's obviously an online offline prompt there as well that you can take the asset down. So that's kind of a first foray into meters. It gives you an example of what you can see in the meter section and how to create a new meter. Now, I did talk earlier about automated meters. And so if I click now, sorry, if I go back to meters and I hit new meter again, you noticed before how there was a setting here to create an automated meter. So it's a very similar process to create a manual meter to an automated meter. But you'll notice that here it has created a new field called source. And what I'm seeing there is REST API. So the one available source we already have in here is our REST API. So if you are using, IoT sensors or an IoT platform that has an open API as well, you can essentially connect that data to MaintainX using the API, and you can bring that data in automatically into the meter. I mentioned a couple of other integration options earlier, and I'm just going to run through this very quickly. But if I go to our integrations tab here, you're going to see the various ways we can connect external sources. So I have actually already set up a connector here for MQTT. If anybody is using an MQTT broker like HiveMQ, Mosquito, any of those types of systems, you can grab data from your machines via that system. I spoke about Ignition earlier. If you're using Kepware or Ignition here, I can set up this connection with Ignition incredibly quickly. How this works is basically a 3-step process. What I would do is I would download the MaintainX module for Ignition. I'm going to create a new Ignition instance here. Let's just say I call it Ignition SCADA. You're going to get a token from MaintainX that is basically just a way of connecting MaintainX to Ignition. So, if you're working with any controls or automation engineers over there, you can kind of carry this message to them that there's a very, very easy system for connecting MaintainX to Ignition. Once that token has been put in on the Ignition side, the connection there is going to be established. And what you can do is you can, on the Ignition side, decide which tags or data points for your machines you want to pull into MaintainX. And what it's going to do is create meters that we just looked at on the MaintainX side that are automatically being populated with that runtime status condition data that already lives in Ignition. And so when I go back to my meters here and I start create a new one, and I go to automated, now when I look on the sources, I'm seeing the Ignition SCADA and the MQTT broker. And these are grayed out right now because I haven't actually chosen any tagged information to pull into MaintainX. But basically, this is where you would find that, right? So if you have set up that connection with Ignition, which, as I showed you, is very, very fast, you're going to select which asset data you want to bring into MaintainX, and now it's going to show here. So essentially, you can create a meter, an automated meter, and you can just select any meter or asset that you want that's already loaded in Ignition. And that's going to help you to bring those readings in automatically. It's going to save you time and also give you more accurate and reliable data there as well. All right. So I'm going to stop sharing there, I believe. Oh, sorry, I just realized there is something more I was going to present here before I hand it back to Anoja. So before we move on from here, I did just want to call out one thing just to kind of wrap this demo. A few best practices for using meters. Some of the things that maybe I didn't cover in the demo that I just want to run over now. So naming really is everything when it comes to organizing the meters, right? So make sure that you have clear, consistent, standardized meter names to make them easy to recognize, because you can pretty easily trip over yourself if you don't have a good system for naming things. And that really goes for any information in MaintainX, right? Make sure that you have that kind of consistent naming convention. Secondly, make sure that the meters are connected to assets. So I showed you an example of that earlier. This obviously helps you to report on the time and costs attributed to each machine accurately. And it also helps you to find that meter info directly from the asset page, as I mentioned before. Remember to review the data to spot trends. The automations that Anoja is going to show you are definitely going to make it easier for you to spot issues in the data, because you're going to be able to kind of automate that process. But even without automations, you can still put that meter data to use just by reviewing the meters that are the most important to you, or perhaps belong to the most critical assets. And then, of course, just be aware of the possibilities of automated meters that I just showed you. If you are using sensors or a SCADA system, especially if it's something like ignition, let your account manager know, and there might be some really powerful workflows you can set up there. All right, so we've set up our meters. They're now collecting data. So Anoja, what's the next step here? How do we turn this information into action, and what do we mean by automations in this context?
Yeah, great question. So let me go ahead and just share my screen here for a second. Now, I do want to clarify, because we're talking about automated meters and now we're going to talk about automations. There is a difference there. I know there's similar language, but when it comes to automations, this is a sort of a separate topic from automated meters. But what are automations? So automations are workflows that trigger actions when meter readings meet specified conditions. So, what does that mean? Like, what do you get out of it? Well, automations are where your condition data actually becomes actionable. So, your meters are tracking all the readings, but automations are what happens when those thresholds are hit. So, as a result, the right work gets done at the right time. You're less likely to miss an issue because the system's always monitoring. And when something does go wrong, the response is faster because you're not waiting for someone to catch it to catch it and manually create the next action. And actually, let's give you a real example of what this looks like. So one of our clients, Coltrack, who we talked about earlier, was spending about 70 hours a week. That's right, 70 hours. That's like the full-time work week of one person, or two people actually. But they were spending 70 hours just on admin work. And then after they rolled out automations with meters, that number dropped down to 30 to 40 hours. So that's almost a 40% reduction. And what's great about that is that, yes, you're saving hours, but it's what you can do with those hours now. Their team told us that it freed them up to actually focus on higher priority tasks instead of chasing paperwork. And they even mentioned that when audit season came around, prep time was basically gone because everything was already digitized and ready to go in MaintainX. So the big takeaway here is this: automations, they turn your raw meter data into real actions. And that helps your team save time, respond faster, and ultimately work smarter. So we've got another poll here, folks. I will acknowledge we didn't give you the best instructions earlier. I noticed that some folks are having an issue with answering the poll. So what you'll need to do is you go to the poll section and you'll see this poll on the screen. It says, what triggers the assignment of corrective maintenance in your organization? To answer the poll, you'll have to hit the three dots that you'll see to the top right of that poll, and you'll see an option to vote on poll. So apologies for not giving you those instructions earlier. We sort of switched up our poll process here and forgot to remind you exactly how to vote. So that should, I believe, fix the issue with some people not being able to vote. But once again, the question here is, what triggers the assignment of corrective maintenance in your organization? And you'll want to select the one that's most applicable. So is it A, findings from routine inspections? Is it B, reported failures? Is it C, automations based on equipment readings? Or is it D, I don't know? That's a fair enough answer. There's no right or wrong answers with this one, but let's see. I think that should be enough time. So what are our results? Okay. So pretty even split between findings from routine inspections and reported failures. And I think that tracks. We hear this a lot from our customers, that inspections are still the main way that teams catch issues. But the nice thing is that automations can build on that by turning those same checks into digital triggers. So you don't have to rely on someone remembering to flag it during an inspection. And then I think the other one was reported failures. That's the other big one. Yeah, also pretty common. That usually means that things are still a little bit more reactive in your organization, and that's normal, right? A lot of teams will start here. But what we see is that once you move away from waiting for failures and you start leaning on condition based triggers, you really start to cut down on unplanned downtime. So let's look at the demo org that we were looking at earlier and actually see how this looks in MaintainX. So there we go. Okay. Now, first off, we'll go through some existing automations we've got set up here before we build one out together. We've got a couple of examples here. So the first one is this Jur paint robot. You can see this 500-hour preventive maintenance automation. And essentially here in the details tab, we can see that every time this meter increases by 500 hours, it automatically creates a work order. So that's great for making sure that you're hitting those interval based checks without relying on someone to remember. And then the second one I want to point out is the Orion wrapper one over here. So this one, it's a little bit different. It's tied to a knife temperature meter. And essentially, if the knife temperature goes above the set limit of 480 Fahrenheit, then this automation will automatically change the asset status to offline. So we can see that here. There's the action. And then this last action that we've got here, the air compressor vibration warning. So this one's set up as a notification only. So when the vibration hits 80% of its threshold, this automation will automatically send a notification. So that way your maintenance team knows, okay, this is something that we need to keep an eye on before this asset hits or before this asset breaks down. So those are three. I was trying to say quick and then three, and then I said qui. Those are three quick examples of the actions that you can create in MaintainX. I will say that the option to create a work order is available to premium and up. And then the other options for sending a notification and setting an asset status offline are available on enterprise. Now, let's actually create one of these notifications together, or sorry, one of these automations together. So we'll click here in the right corner, new automation. And let's say I want to create an automation for my Fanic robot. And I'll do a, let's see, I've never actually used a Fanic robot, but I'll do a change asset status and a work order. So that's the other thing is you can actually combine actions. Fanic, let's say when the meter hits 10, sorry folks, give me a second here. Okay. All right, I think I'm good now. Okay, so let's go ahead and name this Fanic. I'm just gonna actually copy and paste this. You know what, folks? Honestly, typing and talking is very hard. So that's where I got a little messed up there. I'm just gonna copy and paste it just to make it easier for me and not to confuse you folks. So I'll put this title as Fanic Vibration 100% Threshold, and I will copy and paste this description to say create a work order and set asset status when vibration reaches limit. And then we come down here to the trigger section, and this is where I'll actually select the asset and the meter. So I'll hit asset and select Fanic, and then that will bring up all the relevant meters. You can even do this the other way around. So you could select the meter first, and then it will auto-populate the asset that is attached to that meter. And I will make this one is equal or above. So right here, I'll make it is equal, no, is above or equal to, let's just say 10. Let's make it easy. So 10, and then we'll add some actions down here. You can also add a condition to have it only go off between certain hours if you'd like, but I'm going to keep it simple and just get rid of the condition and just create a work order. And for the work order, I'll title it Investigate High Vibration Panic. And for the description, always good to add a description just to provide context to whoever is viewing the work order or the automation or whatever it is. And then assign this to my maintenance team. And then also, if you're creating a work order, we always recommend adding a procedure. So I believe there is a vibration inspection checklist for this one. Yep, there it is. So FANUC vibration inspection checklist. And then I will just hit, oh, actually, I said earlier that we can layer actions. So I'm going to add another action here to change the asset status. So once it's reached this threshold, I want this asset to go off automatically so that people know that it can't be used. And we'll set status to offline inspection. Yeah, I think that looks good. And downtime type, this is required. And we'll set this to planned. Right. And then I will hit create. And just like that, we have created an automation. Now, something else that we recommend is setting multi-level triggers. So in this case, we set up this automation to have a work order created and have the asset go offline at the 100% threshold. But let's say we want to get an early warning. Let's say at the 80% mark, we want to get a notification letting us know that readings are starting to go a little bit higher and that we should keep an eye out. So I'm going to create another automation here. And for this one, it'll be just a vibration warning automation. Try to make the names as clear as you can. And then for the description, there you go. So the FANUC robot has reached 80% of the vibration limit. Please monitor closely. A work order will generate automatically if it hits the full threshold. And then we're going to select that same asset that we selected previously, select the meter, and then is equal to, earlier we put the 100% threshold was 10. So if we want to do 80%, then that's going to be 8. And then we will send a notification. And similarly, we'll send it to the maintenance team. We can either have it sent as individual emails or just have it sent as one. You could choose to have yourself included in the email. And then you also must put in a email subject line and some body. I'll put the same one that I put earlier for the description. I think that's fair. It keeps it consistent and very clear what this automation is. And then I'll create that. And just like that, we've got these 2 automations, so the vibration warning and then the 100% threshold. And so that way at 80%, the team gets a warning, but at 100%, the system will create a work order and set the robot offline. So this way, you're not waiting for failure to happen. You're being active and you're building in both visibility and action at the right times. Now, let's actually trigger this automation. So let's do the 100% threshold. I'm going to go back to the meter section that Colin was showing earlier, and we'll go to FANUC vibration, and I believe I said 100% threshold was 10. So if I record a reading, and you'll either record readings straight from the meters module or it'll be attached to a work order. But in this case, I'm just going to go to the meters module and record it there. And if I go ahead and record, let's say 20, so twice as much as the threshold, what that is going to do is create a work order for the FANUC robot. And I didn't assign that one to me, so it's not right at the top of my list. So give me a second here. I got to scroll. Should be here. So right here, this is a newly created work order that was created because of that meter reading being way too high. And you can see the details here. You can see the asset is set to offline because that was the other part of that automation. So it creates the work order and it sets the asset to offline. And I promise, as you can see here, created at 141, which is 141 for me. So this literally just happened in a split second. So you can see how powerful automations can be. Another thing that I want to mention is for companies who are migrating over to MaintainX, and maybe you've used a previous CMMS or you already have workflow automation set up in another system, we can bulk import automations. So you don't have to sit there and go and create one for each of the automations that you've already created in another system. We can bulk import them. Just reach out to your account manager and they can walk you through that process. Okay. So, some best practices for automations. First off, you want to configure triggers at different thresholds. Think of it like an early warning versus critical action. And you might configure one automation to send a notification when a meter hits 80% of the limit, just to give the team a heads up. And then have another one that actually creates a work order and maybe sets the asset offline when it hits 100%. So that way you're escalating the response instead of jumping straight into downtime. And then number two, base thresholds on manufacturer recommendations. So always base these thresholds off of what your manufacturer recommends. Don't just pull random numbers out of the air like I just did, but for demo purposes. Your manufacturer has tested the asset. They know when your asset typically needs service. So if you set your limits too low, you'll end up over servicing and wasting efforts. And if you put it too high, you can risk missing issues altogether. So, sticking as close as you can to the manufacturer's recommendations is the best way to avoid both of those extremes. Third, use descriptive labels for your automation. So the next one, this seems pretty simple, but it really does make a huge difference. So use clear descriptive labels instead of just calling it vibration automation, right? Try to include the asset that it's on or the meter. Try to include what the automation actually does. So is it creating a work order? Is it just changing the asset status? Is it sending a notification? And that way, if you ever need to audit your automations or maybe skip a work order because two of them overlap, then you know exactly which one does what without having to guess. And then fourth, bulk import when you're scaling. So if you're either coming from another platform or you're just starting to create a lot more automations at once, if you need to create more than 50, then we have a bulk import tool. It saves a ton of time and helps you keep everything consistent. So, again, reach out to your account manager and they can walk you through that process. Okay, I need a sip of water. Colin, can you please remind me what we've got next?
Yeah, absolutely. So that's cool. You know, at this point, we're now collecting readings. We're triggering work automatically, as you just showed. So I think the next step is, how do we know if our CBM strategy is actually effective? So, I know you're going to dive into reporting a bit now. So can you just kind of shed some light on what types of reports folks should look at if they want to measure the success of their condition-based maintenance?
Yeah, for sure. Great question. So when we talk about reporting, this is really just about analyzing your maintenance and performance data to see if your CBM strategy is actually working. It means that the system is tracking your work orders, your asset history, your downtime, even your costs, and also you've got the visibility to drive continuous improvement. Now, the point here isn't to just collect a bunch of numbers and let them sit in a report. The whole goal is to act on those insights, right? You want to use them for to make data backed decisions instead of relying on your gut instinct. You want to reduce unnecessary costs and you want to shift your organization towards performance and reliability maintenance. So here's another powerful example from the same client we talked about earlier, Cold Track. And before using MaintainX reporting, or sorry, before using MaintainX, they were spending about $28,000 a month on parts. But the visibility of reporting, they were able to bring that down to under $10,000. So that's a massive cost reduction, right? And their maintenance manager even said to us, now we know the lifespan of our parts. So if a seal doesn't last 5,000 cycles, we know someone's not doing their job. And meters show a lot of this. So, very specific example to them, but as you can see, meters have helped them cut down costs by a lot. So by combining your reporting with your meter data, you can see how much you're cutting, your how much cost you're cutting, um, and try to see if your CBM strategies are working effectively. So we've got another poll here just before we get into the demo section. And again, folks, head to the poll section on your screen and then hit the three dots that are right above the poll and hit vote on poll. And that way you'll actually be able to vote on the poll. And for this one, the question is, which statement best describes your organization's approach to CBM insights? Is it A, we have full visibility and take action on insights? Is it B, we collect data but aren't sure how to use it? Is it C, we rely on manual reviews and guesswork? Or D, we don't track CBM insights at all? I mean, if you haven't started a CBM program, then good chance that you're not tracking those insights. But let's see what kind of answers we've got here. Give it a couple more seconds to close it off. Remember, folks, there's no right or wrong answers. This is just for us to get to know you folks and see where you're at in your maintenance journey. Okay. The C number is going steady. Okay. Okay. Oh, I think we can close it off. I think that's a good amount of time. So let's look at results. Okay. Where did my results go? Oh, they're there. Okay, so as we can see here, 43% don't track CBIM insights at all. Again, it it makes sense, right? You're definitely not alone. As you can see, some teams are just starting their CBM journey. Um, and then we've also got a good amount of people on rely on manual reviews and guesswork, and that's also super common. We hear this all the time. The challenge is that manual reviews take a lot of time, and guesswork can only get you so far, right? The nice part about reporting is that it automates a lot of that for you, so that you can spend less time piecing together different insights and more time actually solving the problems in your organization. So think those answers pretty much track with what we were thinking they'd be. So that's always nice. So let's get into the demo we were looking at earlier and actually look at the reporting features that we have. Now, one quick thing actually before we get into reporting, Colin, I believe you shared this earlier, but in your meters module, within each meter, you can see that there is this meter reading graph, right? And this is a great place to start off. It lets you see your recordings plotted over time. And what you want to look for here are any patterns. So if we see that the line is steady and predictable, then that usually means that the asset is operating as expected. But if we see any irregular patterns or any like sudden spikes like we're seeing here, then we know that there could be some potential problems. And this ties directly back into condition-based maintenance, right? These consistent readings, they confirm stability, and anomalies like the one we're seeing over here should prompt us to take action, either by scheduling an inspection or triggering an automation. Now let's go into the reporting module and look at a few key reports here. So the reports that I'm going to show you live in the asset health tab, and this is a part of our higher tier plans. But even if you don't have them today, we'll walk you through them so you can get a sense of how organizations are measuring the impact of condition based maintenance. So first report that we'll look at is most problematic assets right over here. So this report, first of all, I love the name of it. I think it's so funny to refer to assets as problematic because that feels like a very human term to me, but that's what they are, right? These assets are your bad guys. They are the repeat offenders. And this report is generating the most work orders and downtime. So these assets are probably costing you a ton, a pretty penny, and if you see the same asset keep showing up, then that's a clear signal that it needs attention. So that could either mean adjusting your CVM thresholds or reviewing your procedures or even planning for a replacement. But the value here is the focus that you get, right? So instead of spreading your team's energy evenly across all of your assets, this tells you where CVM can deliver the biggest impact. Another report we'll look at is total downtime. So that's right down here. And the total downtime report splits your downtime into two categories. So it'll split it into planned and un- unplanned. And this can also show you where your CVM strategies are being effective. So over time, you want to see the unplanned downtime going down and your planned downtime going up. So your planned downtime is predictable and it's controlled, and it means that you're addressing issues before they cause a breakdown. So if you can chart this quarter over quarter, you can even show your leadership how much downtime you're saving every month, and that can really help you create a very clear cost benefit story for your organization. Another important point is that when these reports are fed by real-time data from meters, so essentially the automated meters we were talking about, they're much more accurate, right? They're constantly tracking downtime. They have it right on time as well, like you know for sure that this asset went offline at a certain time versus just guessing. So the meters are really great for this. You're not relying on someone to remember to log when a machine went offline. It's all just being automatically fed into the system. So that's one of the cool things about those automated meters that we talked about. And then one last report we'll look at here is MTBF and MTTR. So just to the left of the total downtime report. And first off, these are two pretty important metrics that we recommend tracking. So MTBF, that's mean time between failures, and then MTTR, which is mean time to repair. These are, I feel like I could say, two of the most powerful measures of CBM effectiveness. And increasing MTBF means that your assets are lasting longer between breakdowns because your CBM strategy is catching any issues earlier. And then a decreasing MTTR means that your team is resolving issues faster. So that's because automations ensure that the right work orders are created with the right context so that repairs can be more efficient. And then, yeah, I'd say these are some of the key reports that we'd recommend looking at. This is what helps you turn your condition based maintenance strategy into more of a numbers driven story that you can then provide with leadership. So together, these reports, they let you move beyond collecting data. And oh, actually, one more thing I wanted to mention is instead of looking at all these reports separately, you can even create this custom dashboard. So you'll see this custom dashboard option over here. And then on each of these reports, you can add them to a dashboard. So that way you can see them all on the same page instead of having to go and look at them all separately. So that's another cool feature that you can use in the reporting section. Okay, now when it comes to reporting some best practices. So, first off, evaluate the balance of planned versus unplanned maintenance to measure CBM effectiveness. So, the reports that we looked at earlier, right? The total downtime report splits your downtime into those two categories. And that split is one of the clearest signals of CBM effectiveness. So, over time, again, you want to see unplanned downtime trending down and planned downtime trending up. Next, we've got use multiple reports together for a complete picture of CBM effectiveness. So don't look at each report in isolation, right? The real value comes when you can use them together. And then, for example, you can put total downtime might show you that unplanned downtime is decreasing overall, but the most problematic asset report could reveal that one piece of equipment is still driving most of the issues. So yeah, you can build dashboards that pull multiple reports into one view and then filter them differently and compare trends side by side. And then last year, we've got review performance trends regularly to spot opportunities for improvement. It's kind of one of our best practices early on in the session as well for meters, but it really is important. You want to review your performance trends regularly. So reports like MTBF and MTTR don't mean much if you only look at them once, right? The value comes from watching them month over month or quarter over quarter to see if your assets are lasting longer between failures and if your team is repairing faster. So those kinds of trends can tell you whether your CBM strategy is driving lasting improvements within your organization. Okay, I need water again. So Colin, I'm going to bring you back onto the stage. And can you walk us through some of our key takeaways for this session?
Yeah, happy to do so. So my three key takeaways are really to understand the three fundamental concepts here and how these three things fit together and the role they play in a condition-based maintenance program. So meters, like I said, these form the foundation of CBM. This is where you're gonna gauge your equipment condition and get the data that you need to spot issues early. The automations, these are things that can actually help you put that data into action. This is where you're going to use it to trigger the right action at the right time. And that's where you're going to help to, like you said, improve your response time and reduce those downtime incidents. And then the third thing is just reporting, right? So that really closes the loop. That helps you to understand how your operation is performing and measure the effectiveness of the program and obviously get the insights you need to keep improving. So yeah, all these tools together, that's how you create a proactive CBM strategy. And I think really becoming familiar with them and understanding how they fit together is really the key takeaway here.
Awesome. Thanks for those key takeaways, Colin. Okay, now we're going to get into our frequently asked questions section. So these are just some questions that we've compiled, pretty much what they're called, or frequently asked questions that a lot of our customers tend to have. They're pretty common questions. So we're going to run through these one by one. And Colin, the first question here is, for a company that's just getting started with MaintainX, what's the best first step when it comes to setting up automated meters and integrations?
Yeah, and I've seen a few questions as well in the Q&A about this one. So if you're just starting out and you want to set up automated meters, a good first step is going to be to connect with your account manager, right? The right solution for you is going to depend on what your tech stack is today, or at least what devices or platforms you're considering investing in, if that's where you're going. So I gave a few examples earlier. If you are using Ignition, Kepware, MQTT, we can set you up with those connectors pretty quickly. We do have the API as well, which I showed you briefly earlier. And so you can use that to connect your devices. We also have our integration services team that can do integrations for you as well. So I would say, first step, reach out to your account rep, let them know what you're using or what you'd like to connect, and we can take it from there.
Awesome. Great. Okay. Second question. In what situations would you recommend sticking with manual meters instead of investing in automated meters and integrations?
Yeah, so good question. Automated readings are really good for high frequency or critical metrics. So something like vibration is a great example, right? Just the nature of it, it's very high frequency. So you'll probably want to create an automated meter for that. And then any assets that are critical to the running of the line that you need to be taking the reading of very frequency in order to protect that machine and protect really the running of the operation. There are plenty of cases though where manual readings are going to be totally fine. If you only need to log a reading once a week, or if the data point isn't particularly critical to uptime or safety, then it might not make sense to invest in sensors for something like that. So it really depends. But what I will say is that if you're looking at this long term and you are aiming to do predictive maintenance, like a lot of folks are in the long term, you will want to start connecting more data points at a higher frequency, even if you're not necessarily triggering actions from them in the ways that we showed today. So I think this is an example of why the ignition connector, for example, is so powerful, because when you do start connecting your data points, lots of different data points, you're really connecting an incredible amount of context to MaintainX. That's exactly the type of thing that predictive maintenance is really built on.
Yeah, so definitely it depends case by case. We're not just pushing automated meters and sensors onto everyone. There's going to be some situations where it works better and some where you're maybe better off doing another method. I do want to call out that we are at 2 o'clock. We're going to keep going. We're almost done, I promise. But if folks do need to drop off, remember, we will send out a recording. But for anyone that wants to stick around, feel free to. We're still here. Obviously, we have to finish. So, Colin, third question that we've got here. This one's a bit tricky. So, if we have two automations that overlap, for example, an oil change every 5,000 kilometers and a full inspection, which includes an oil change every 20,000 kilometers, is there a way to prevent duplicate work orders when both triggers occur together?
Yeah, so right now there isn't a great way to suppress one automation from running if another is also triggered. So MaintainX is going to generate both work orders if both conditions are met. I would say in those cases, the best practice is really to manage it directly via the work orders module. So, if you see two work orders that overlap, you can simply skip the one that isn't needed. I would say that's why clear naming conventions are so important, because when you set up that automation, because when your work orders are labeled properly, it's going to be a lot easier to tell which one you can skip without losing track of the work that actually matters.
Gotcha. Okay, cool. Fourth question. So, sensors and automated meters are an added cost, and sometimes it can be tough to get buy in from leadership. How can maintenance leaders make the case for investing in sensors to support a CBM strategy?
Yeah, so I think there's a lot of appetite right now for this, and it can be and challenging to get buy-in and also to prove the value there. I think start off by showing your leadership the gaps in your current strategy. If you are doing PM, but you're still experiencing equipment failures, repeat failures, perhaps that maybe are coming down to the same types of issues. you can show that that is an example of really a challenge that you face that could be solved with doing condition-based maintenance. So it's really about starting by framing the cost of not having it and then propose a pilot program, right? So try to make it smaller for people. Maybe set a certain asset or an individual line as your pilot project, your POC. Use that to demonstrate the value. And then, once the leadership sees the value of that smaller project, it's going to be a lot easier to get the buy-in you need to scale it across more assets and more lines.
Okay. Yeah, that sounds like a good plan. Start small, right? You don't have to go all in all at once. We can take baby steps. That's very important. Okay, last question for the frequently asked questions section. When I look at my reporting and insights, it's hard to tell whether the asset is offline because of preventive maintenance versus offline because it was reactive maintenance. How can I differentiate?
Okay. Well, when you set the status, you can indicate there whether it's planned or unplanned. So I would say make sure you're using that feature as diligently as you can. Once you do that, you're going to be able to see your planned and unplanned downtime in your reports in the asset health module that you just showed, Anoja. You can also see downtime reasons on a more granular level in that unplanned downtime reasons report. So that's going to give you that kind of clarity that you need over the planned versus unplanned. But remember, that is an enterprise feature as well, of course.
Gotcha. Okay. All right. Thank you so much, Colin, for being here today and for sharing that wealth of knowledge that you've got. We really appreciate it, myself
Absolutely.
and everyone that's here today. So we're getting to the end here, folks. Now, some additional resources for you, and also one last poll. Okay, we create these educational experiences for you guys. Okay, we want to make them as valuable as we can for you. So we've got this last poll, just asking if you could rate the value or rate the experience that you had in today's webinar. Please be honest. Our feelings will not be hurt. Again, we want to make this as valuable as we can for you. So you'll see that poll in the poll section, just asking you to rate out of 4 stars what you thought about today's content. And then some additional resources if you feel like there's more learning you need to get done. We've got MaintainX Academy. This is our in-house learning platform where you can take some courses, you can watch videos, you can see all of our past webinar recordings there to learn all about MaintainX and how to use the features. And then there's also MaintainX Community. This is a really great platform to connect with other maintenance professionals. I think I saw in the chat people talking and like sharing their LinkedIn. Here's another great place where you can go specifically for maintenance professionals. So definitely post your questions in there, start a conversation, and connect with other folks like yourself. And then lastly, if you want to speak to an expert and you want to book a demo, you will see a link pop up on your screen there where you can go ask some specific questions about your organization. Okay, and then so earlier, I'm so excited about this. I mentioned an exciting announcement. We have our next in-person event coming up in Atlanta. So this event is happening November 13th to 14th. It's a free 2-day event that's focused on maintenance and operations best practices. There will be some certification programs. We'll have AI workshops and a ton of networking opportunities. Our events always get amazing reviews. People love coming out. So then we have a lot of fun. Our last one was in Denver in August, and I was there. And I'll be at this next one. So if you want to meet in person, I'll be there. And a bunch of people that are even cooler than I am. So definitely come out for this event. Again, registration and meals for the day are completely complimentary. So if you want to know more details about how to sign up, just reach out to us and we can send you a link. And you'll also see a link in the follow-up email with the recording for this webinar. So thank you so much, everyone, for attending Condition-Based Maintenance 101. Please remember to fill out the survey that you also get in the email if you can. Again, I really want to make these experiences valuable to you folks, so we appreciate all of your feedback. Be as honest as you can. And thanks again, Colin, for being here, and we'll see you all at the next one. Bye for now.
Yeah, thanks everyone. See ya.